being able to fly a helicopter on Mars is actually a huge achievement, mostly because it was technically thought to be impossible up until, I guess, last year. As a matter of fact, some people thought that it's not possibly going to work, for one reason or another. I've actually explored some of these reasons in one of the older videos, where one really specific proposition and explanation was actually because of the amount of electrostatic electricity it was thought that all of this is going to generate, making the flight pretty much impossible. And that's of course because of the speed of the blades, that's basically over 2000 times per minute, which does have a possibility to create a lot of static that would then destroy the helicopter. But as we now know, it works, and it works really well. And so because of this, it's sort of natural to ask the next question. Can we now fly something else? For example, an airplane, or maybe a balloon? Can we actually bring a lot of other equipment and technology to Mars and make it work there as well? Well, actually, a Mars aircraft is a mission that we're going to be talking about very soon, and it's currently being tested and developed as well, but that's not what I wanted to focus on today. Because my personal question for many years was, can we fly balloons on Mars? Can we have what NASA refers to as the aerobot mission? Basically a kind of a passive flyer that uses the idea of buoyancy, or essentially some kind of a balloon that flies around on a different planet. Now, as you might already know, or you might have heard from some of the previous videos, the first ever mission to ever fly on another planet was not the Martian helicopter, it was actually a balloon. It was a balloon on the planet Venus. And this was part of the program that was launched in the early 80s, that was actually a collaboration between the Soviet Union and several European countries, with France contributing the most. And this was known as the Vega mission. It was actually a multi-step mission that was technically trying to explore the Halley's Comet, but it also had the secondary mission of landing on Venus and using the balloons in its atmosphere. And that's actually the most exciting part, which kind of takes me to this less-known French astronomer / astrophysicist who kind of proposed this and who was super passionate about making this happen. If you're from France and if you're slightly older, you probably know who I'm talking about. Jacques Balmont, a brilliant French astronomer who passed away back in 2020, who essentially pushed for this program in the early 80s, and he was so passionate and so excited to have this happen that he basically designed and developed everything. And he basically designed the so-called Venus Vega balloons when he was the chief scientist for the French Space Agency, known in France as the National Center for Space Studies, or CNES. And because of his passion and his ability to develop these balloons from scratch, he was able to convince the Soviet and the French government to essentially include them as part of the Vega mission, and they did, and it worked really well. And so when they were deployed in the Venusian atmosphere, they worked for approximately 46 hours. The actual balloon looks something like this. And they collect the data, they send the data back to planet Earth, and eventually after 46 hours they run out of battery, and for all we know, they're still flying around somewhere in the Venusian atmosphere. Although there is a high chance that the sulfuric acid might have finally eaten through the balloon's cover, and they basically popped and are now somewhere on the ground. But the important part here is that the helium balloon worked, and it worked really well, which gave Jacques Balmont an idea of now trying this on a different planet Mars. And he actually worked on this for many years. As a matter of fact, the mission was very close to being finished and being launched to Mars to be tested in the early 90s. Then the Soviet Union fell apart, Russia became super corrupted and lost a lot of money, and the mission was cancelled over time. But the main idea behind the mission was definitely feasible, and it almost happened. In other words, we were super close to having not a helicopter as the first mission on Mars, but an actual air balloon similar to the one on Venus. Now we're talking about the flying mission, of course. And technically this could have been the first long-term robotic mission before the NASA's rovers. As a matter of fact, apparently the French agency has actually conducted quite a lot of experiments using the so-called Montgolfier balloons, performing over 30 flights in the 70s, going all the way to the early 90s. The word Montgolfier usually refers to the so-called hot air balloon, basically a balloon that heats up the air and makes it fly above the ground. Although in this case they would not really be using air, but they would actually be using either helium or hydrogen. But more about this in a few minutes. The important part here is that it worked, and they've tested this on Earth, reaching the altitude of about 35 kilometers. And that's actually part of the Earth's atmosphere that's very similar to the surface of Mars. And interestingly, one of their balloons was able to stay afloat in that very high altitude for approximately 69 days. Which basically means we had the technology to launch all of this back in the early 90s. But because of the cancellation of the Russian Mars 96 probe, and the eventual failure of this entire program, we unfortunately never got to learn what would happen if the balloon was actually delivered to Mars. But my question was always, can it work? Would it work? If we were to send a balloon there, would it actually fly? Would it be better than a helicopter? Can it stay afloat for a long time? And so in this video, I wanted to explore some of these ideas, talk a little bit more about the science of a flying balloon on another planet, such as Mars, and also talk about what NASA is actually planning. Let's start with the science. So first of all, NASA is planning these balloons and similar missions to planets like Venus, because this is something that we know works really well. But what about Mars? Well, when it comes to balloons, it's really all about buoyancy and pressure. Buoyancy is of course the reason why the balloon goes up in the air, and the pressure in this case adds to the amount of force that sort of lifts the balloon. When it comes to simple balloons, like the ones that we use at birthday parties, they generally don't survive very long. As a matter of fact, most of them very likely pop at the altitude of about 10 kilometers, assuming that they're filled with normal helium. But some of the more advanced balloons, specifically meteorological or scientific balloons, can easily reach altitudes of 30 kilometers or even higher. The current record belongs to the Japanese Space Agency that launched a balloon known as BU-60 that you can learn more about in the link in the description below that explains what they did back in the early 2000s, that was able to reach the altitude of about 53 kilometers, which if you were to compare to the surface of Mars, would actually be much lower in pressure compared to what you would experience on the surface of Mars or even in some of the higher altitudes. In other words, theoretically, this balloon could fly on Mars. And that's because, as I mentioned earlier, the density on the surface here is equivalent to the density of air at an altitude of 35 kilometers or 22 miles above the Earth's surface, or basically the atmospheric pressure of about 0.6%. But the atmosphere of Earth is slightly different from the atmosphere of Mars, so the gas that we use here does actually matter. Normally, all of the high altitude balloons are filled with helium, because it's lighter than the air, and also because, unlike hydrogen, that's also much lighter than the air as well, it doesn't explode when exposed to oxygen. The famous Hindenburg accident was unfortunately because of this, because hydrogen in this case reacted with oxygen and exploded, causing the disaster that basically ended the idea of hydrogen-based balloons. And so let's say that we bring some kind of a balloon to Mars, and we bring a balloon with either helium or hydrogen. Would it work? And so here we have to do a bit of a scientific analysis and very simple math to figure things out. How do balloons work on Earth? So let's just say that this is a helium balloon floating in the air. In this case, a cubic meter of air on Earth at sea level is going to weigh approximately 1.3 kilograms. But a cubic meter of helium is going to be much lighter, approximately 0.2 kilograms, whereas hydrogen is going to be even lighter at 0.1 kilograms. And because of this difference, it means that the balloon is going to be receiving a kind of a pressure from the air itself, and is going to have a lifting capacity of the difference between the weight. In case of helium, it's 1.3 minus 0.2 or 1.1 kilogram, which is quite a lot of lift. It means that a balloon that's approximately 10 cubic meters in size is going to be receiving almost 10 kilograms of lift. Actually, even a little bit more than that. And the bigger the balloon, the more lift it's going to get. With hydrogen is going to be just a little bit more. But naturally, the atmosphere of Mars is very different from the one on Earth. It's much thinner and produces way less lift. So while on Earth, a cubic meter is approximately 1.3 kilograms, on Mars, a cubic meter of atmosphere on the surface is approximately 0.02 kilograms, or basically 20 grams. While 1 cubic meter of helium is going to weigh approximately 0.001 kilograms, or approximately 1 gram. For hydrogen, it's going to be about half a gram. And so even though helium on hydrogen is a little bit lighter, the actual lifting capacity of the air or of the Martian atmosphere is dramatically lower. It means that to basically lift a heavier object, you suddenly require much higher volumes of either helium or hydrogen. In rough terms, you need about 500 times as much helium on Mars to lift the same object as high up in the air as you would on Earth. Or in other words, the balloon has to be about 500 times bigger. In more practical terms, a balloon size of a house would only be able to lift approximately 1 kilogram of material, and that includes the weight of the balloon itself. So if the balloon itself is made from slightly heavier material, in order to prevent it from popping, it might not even be able to fly if it's over 1 kilogram. So for example, in order to lift a larger rover or some kind of a probe that's possibly hundreds of kilograms in weight, you would need a balloon larger than your typical stadium. That's a huge balloon. That's bigger than any balloon we've ever created here on Earth. But that's of course using typical balloon technology. The French studies from the 80s and the 90s determined that if we were to use balloons using what's known as the hot air balloon, it might be possible to actually use hydrogen to lift things much more efficiently. And that's something that NASA has determined as well, using their own tests that happened afterwards. NASA has what's known as the Wallops Flight Facility that usually does a lot of different flight tests. The link for this and other stuff is in the description below, that essentially show that some of these balloon designs could be feasible for Mars as well. With the most exciting design being known as the solar heated balloon, also known as the solar balloon. The balloon that essentially gets a lot of its buoyancy from the air that's heated by the solar radiation. And so essentially by heating the balloon using the sun itself, it becomes possible for these balloons to float during the day and then land somewhere on the ground during the night. That's one of the possible missions that's explored by NASA. But obviously by landing in the balloon at night every single night, it does create a lot more opportunities for the mission to fail. So it's probably better to have something that's a little bit more stable and that always stays in the air, independent of the temperature or the time of the day. And so in this case, instead of using the solar balloon, it might be better to use what's known as the superpressure balloon, the balloon that provides much more stability during the long duration missions. We've actually briefly talked about this in one of the last videos that should be somewhere right there or in the description, but in the last few years, NASA's experiments determined that by using a kind of a pumpkin-shaped balloon, it might be possible to have a permanent telescope orbiting around the planet for many weeks or even months at a time. And by using a similar shape and a similar technology, it could be possible to have something on Mars as well. And so there's at least one paper that you can find in the description below that was published by NASA a few years ago that goes through a lot of detail about this. And it essentially determines that it's quite possible to have some kind of a balloon mission one day in the future. Although in this case, using helium is probably not going to be very efficient. Because Mars does not have much oxygen and it's free form in the atmosphere, using hydrogen is much better. It's lighter and it's also a little bit easier to deploy. And so in case of a balloon mission on Mars, hydrogen works best. But it also has to be super pressurized as well, basically under a lot of pressure in order to create the most lift possible. Although it does only provide approximately 5% more efficiency when it comes to lift compared to helium. But helium is more expensive and hydrogen is everywhere, so there's that advantage as well. Although unfortunately the so-called MAVVAP mission, or the Mars Balloon Validation Program, has been only talked about for the past 2 decades. It still hasn't happened. And I was actually wondering why. Well, it turns out that during the exploration missions by NASA, and even during some of the earlier French missions, they actually determined that the most difficult part of this is the deployment. It's surprisingly difficult to inflate and to pressurize the balloon without popping it and without basically causing it to explode or to fly away uncontrollably. We're talking about remote conditions on Mars, not here on planet Earth. And so in other words, one of the main reasons why NASA never really tried this mission is because they couldn't really figure out how to make the balloon inflate and how to make it fly afterwards. With the other main challenge being the reasons. So in this case, NASA really needed to have a mission that needs a balloon, not really a balloon that for some reason needs to have a mission. Or in other words, why bring a balloon to Mars if you can achieve everything by using a rover? So in this case, it was basically kind of redundant. But recently, the scientists realized that we could use a magnetometer, an instrument used to measure the magnetosphere, that could then be used on Mars to map the magnetosphere of the entire planet. And all of this could be done by putting it on a balloon that flies around the atmosphere and collects all of the data over time. And so in other words, at least one type of a mission could definitely benefit from having a balloon on Mars. But at the moment, nothing is practically being planned just yet. It could definitely work though, it's just not being explored actively by any of the space agencies. Although I personally would love to hear about a balloon on Mars. I mean, how cool is that? Especially because there are at least 3 different types of balloons that could definitely work here. We have the high pressure helium balloon that would most likely fly at very constant altitude and would be a perfect opportunity for some kind of a long duration mission. We have the hot air balloon that would most likely use solar heating in order to have the balloon fly really high up in the air during the day, but then possibly land during the nighttime, which could also provide the opportunity to explore the surface of Mars. And then we have the super pressure pumpkin-shaped balloon that's usually used here on Earth for a lot of different atmospheric studies, that's known to be able to circulate around the planet for several weeks at a time without losing any altitude, by being able to maintain constant high pressure on the inside, but also having a very specific shape that provides the most stability and the most buoyancy, which essentially means that these missions, if they ever occur, would very likely work. It just, right now, we don't really have a reason for any of these missions. It would definitely be cool, and it would definitely be quite interesting, but in terms of the actual science or experiments, it would not really be that useful. Unless we use the balloons to measure the magnetosphere, or we can figure out some other important reason to use them, something that cannot be done by anything else, like for example, a rover. And so that's kind of where we are right now. The theory is there, it can definitely work, assuming the right shape and the right pressure, but there's just no need for it yet. And because these missions are pretty expensive, it would be difficult to convince NASA or any other space agency to launch one anytime soon. But it doesn't mean that it's not going to happen. As a matter of fact, chances are it might happen very soon. Because as far as I know, nobody expected the helicopter mission to ever work or to even happen. And so, for all we know, balloons are next. Well, until then, or until we learn something else, that's kind of all I wanted to mention. Check out other videos about Mars and the experiments on Mars in the videos in the description or possibly somewhere right there. And subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.